Hello, 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 hello. Testing. Is the audio all right? Hello, hello, hello. Is it clear? Just testing the audio here. Uh, Try now. Can you hear me? Okay, guys. I think six people are here right now. Let's wait for a few more people and then I'll start. Who are all here? Can you just introduce yourself in the comment if you don't mind? Can you guys introduce yourself in the comment section? Hello. Uh, I see six people here. Can you all introduce yourselves until everyone else, a few more other people come on? Oh, hi, Charit. We'll wait like another 5 6 minutes probably. Let's see if at least 10 people come on, then we'll start. Just do a thing. Let me just set up the video a bit more. Uh, Minute. It seems proper here. Mm, uh, is the video clear, guys? I think it's only in 480p. Let me just see where I can change it. Mm, just a minute. Okay, I'll just wait for 2 more minutes and then start. Uh, I hope everything is clear. I hope the audio is clear. Yeah, everything seems to be working fine. Okay, so I just advise you all to install Git and GitHub if you haven't already. So let's just go to type git download, maybe the GitHub desktop, the GitHub website. So just download it for your operating system, and then also download GitHub desktop. So if you haven't already, and then I would also advise you to download VS Code, as I will be showing you a few tricks that will be really good. So they do download VS Code, and it really provides a very easy way to actually perform all the Git actions which I'll be showing on command line in a visual representation. So it's going to be really cool and easy stuff to do. So please download this too. This is the code editor I'm going to be using. So let me just see how many people have joined. Okay, I think we are good to start. There are 12 people. So if everybody is with me, I hope everyone is with me, and please do comment. I am looking at the comments live. So if you have any doubts anywhere, please do leave a comment, and I will look at it, and I will stop the session and clear your doubt, or maybe I'll clear it all at the end. So please do interact with me throughout the session, and please do leave comments so I can know that everybody is with me, and I'm just not going away too fast or too slow. Okay. So first of all, thank you all for streaming in. This is really a good opportunity for me. This is the first time I'm streaming, so thanks for watching, tuning in, and supporting me. So let's get started. Just a minute. Okay, let's get started. So, going about GitHub, Git. So, I hope all of you know there's a difference between Git and GitHub. They're both not the same. So, GitHub originally arrives from a thing called version control. So, version control is a type of controlling mechanism, a software, which controls the version of your code. So you would have seen that typically applications ship out in different versions, and every time you update an application, there is a different version associated with it. So this is what version control is all about. It's about making changes to the previous code, and then keeping track of them. And why and how GitHub helps, how Git helps you in this is a really cool thing. And if you're a programmer, if you're a computer science student developing projects, and if you haven't used Git yet, you should definitely do it because it is the most important tool and the best tool to use as a software developer, which will help you track all of your changes and will just make your life easier when you're testing different stuff and we are going through different stuff. So let's get right into it. So this is what Git does. It tracks everything you do in a code base. It basically tracks every time you create a file, you add a new line, or you remove a line, anything, and it just tracks it just like that. And it is taking count of everything that is going on, like every new file you add and every new line you add. So why is this important? Uh, let's see for an instance where you have a project ongoing and you have created a project, it's working fine, but then you want to make a few more changes, but it's kind of risky, like because you don't want to break anything you have done already. So what you would do typically, if you didn't know, GitHub or Git would actually make a copy of that code, keep it in a separate folder, and then keep another copy, and then make your changes and test it out. But what if you had like 100 changes? So making 100 copies would be kind of difficult, I would say. This is where Git comes into play, and more importantly, the second most important feature of Git is collaboration. So if you worked on a big project, you would know that you definitely wouldn't be writing all the code by yourself. So there would probably be like at least 4 people in a team, or if it is a large project or an organization, it would be hundreds of people. So how would each people keep track of every single line of code that every single person is doing? So it's kind of difficult. I can't just communicate with everyone saying that I added this line in line 18 and you add it in the next line. So it's difficult to integrate everything when a lot of people are working on it. This is where Git comes into play. GitHub also comes into play. So it helps you synchronize code between different people, so that whatever code changes you make and whatever code changes that your friend makes, it helps them synchronize them, and both of you have the same code base now. The changes that your friend has made and the changes that you have made, both of them are shifted together and synchronized between your two systems without you coming in physical contact, copying it anywhere and sending it to anyone. It's just synchronized with a few commands. So this is the main part of it. If you have a original branch going on, if you have a original line of if you have a stable code base which is already working and you want to test out something, you can easily do it without changing anything here but following a separate path of line, and then bringing those changes back once it's working. So as I said, you can track all of your changes. You can every time you create a file, add a new line or remove a line, Git is tracking your changes, and you can bring them back. If you don't like something that has happened in the future but you want to bring back the previous version of code, you can absolutely do that. That is the magic of Git. So that's how it works. So like I said, Git is a version control system. It keeps track of your changes in the code. It synchronizes code between two different people. You can use it to test the changes to the code without losing the original, and you can revert back to the old versions of the code. So let's get a bit of hands-on right now, shall we? So yeah, if you want to follow along with me, you're welcome to. I hope you have downloaded Git and GitHub desktop and installed it. This is how GitHub desktop would look like if you installed it, and you would have to sign in. Anything you do, I think the first thing that it asks you is to sign into your on your online GitHub account. So do that, and also make sure that if Git is not showing up here, or if it is uh, if you want to use it in the command prompt, add it to your environment variable. Else what you could do is easily use git bash from here. So what I have here is a simple project, which is a Java file. I've opened it in VS Code. This is what the project looks like. It is a swapping project. It just swaps two numbers. So I hope all of you can see it, or let me just make it bigger. So yeah, this is how the project looks like. Just since the video is streaming in a bit low quality, is everything. So yeah, this is my project folder. So what I will do now is how to start a Git repository. So in Git term, every folder where all your project files are is called a repository. So the way you start it is open git bash here. First I'm going to go through some of the basic commands, and then I'm going to show you how you can actually do this without typing the commands and in a GUI based application like GitHub Desktop or VS Code. So this is how you would start a repository. You would type git init, then it would say initialize an empty repository, and immediately you'll see that an empty folder is here, which contains all the information that Git uses to track your code. So let me just start making changes in my repo. So this is my GitHub repo now. This folder containing a Java file is my GitHub repo, and remember Git is tracking everything I do here. So what I can do is the first command would be git status. So you can see it shows the status of the files that are available. So it shows on branch master. I'll talk about branches in a while. So on branch masters and no commits yet, and then untracked files. So the concept of tracking is what I've been discussing, that Git tracks your files. So to actually for Git to actually track them, you have to add it to the tracking path, like where the Git tree where the files are getting tracked. This is how you do it. So you can see there's only one file in the repo, and it's not being tracked is what it says. So what you would do is git add and then the file name. This would add it to the tracking system. So now if you type git status, you can see that it's being tracked, and any change I'll make to this will be reflected, will be committed. So since I've added it to tracking, I will move on to the next concept of Git. Every time, so after you added your changes to the tracking tree, what you'll do is you'll do git commit, and this is the command for git commit. It is git commit -m with a descriptive message. Since this is my first commit, I'll just type initial commit. So this message is what allows Git to uh, actually identify which commit is what, because each commit has a git hash, is stored by git hash, and there is nothing you can that is human readable. So a commit message always helps to know which commits, what changes were done in which commit. So you can see here it shows one file change to 22 insertions. That means I've added 22 lines of code. So now if I type git status again, will show on branch master nothing to change, working tree clean. So this means that you have committed all your changes, you have made a checkpoint. So this is how Git works. Every commit is like a checkpoint. Now this checkpoint is similar to checkpoints in a game. So anytime you make some mistakes in your code base, and for some reason your build fails, whatever application you were building just fails, and you don't know what to do, all you have to do is revert your code back to this checkpoint, this commit called initial commit, and you will be left where you left off in that commit. You'll be reverted back. So the next thing, next useful command is git log. So git log just shows you all the commits you have done. So right now I've done one commit with initial commit, and the author is me, my email, and it also shows the date, Thursday, March 26th, and the time. Now this would be really useful if there are hundreds of people actually working on the project. So it would show it would show actually which commit was done by which author and what they changed. So this would be really useful. So let me make another commit. Let me just show you that it actually works. Let me change something. So I'm gonna make it 45. So immediately you'll see that in git status again, file has been modified, and I have to track it again by git add, because previously I committed it. So now it's added to the working tree, and any changes I make to it will be tracked now. So I can again make a commit saying git commit -m with a descriptive message of let's say second commit. Okay, so yeah, it shows one deletion, one insertion, which means that I deleted a line and I added a line, but actually I didn't, but Git interpreted it that way. So now if you see git log, you'll see that there are two commits showing. So this is how git log works. It shows you the history of commits which you can jump back to. So let me just move on to another concept here called branching. So branching is a really important concept when it comes to collaboration. Suppose, like I said, if there are 100 people working, everybody working on so many changes and then they're pushing it to the same branch at a time would cause something called as merge conflicts. Now, merge conflicts are, where is my slide? Yeah, let me describe you how it is. So this is how a merge conflict would look. If there's the same person, if there are two different people or more who have changed the same line of code in the same file, now Git would not know how to handle it. It would just not know if it should change your changes which you have made or their changes. This is what it looks like. So it will show your changes here. This is what you have changed the file to, but this is what the other person has changed the file to with this commit ID. So here it's a conflict because there are two same lines with two different codes, meaning 2 and 0. So what you have to do here is to accept the changes or keep your own changes. So you can either remove this and accept whatever is coming in b equals 0, or you can keep your own change, remove this, and remove all these lines, and then keep your own change. So a better way to handle this, I would say, is a concept called branching. So what branching allows you to do is actually with what I showed in this slide. Yeah, branching what works like this. So you're on a master branch and you want to kind of test out a new feature. You want to develop something new, but you don't want to ruin the code base. You just want to test it out. So what you're going to do is create a new branch with whatever you're testing. You can name it and whatever you want. And when that feature is stable, then you're going to merge it to the original branch, which is master. Let me show you how that works. So right now you can see that so this is how you create. Right now you can see that my current branch is the master branch. So how I will create a new branch is by the command git branch -b. You can, if you just type git branch, it will just show you the number of available branches. But if you want to create one, you type git branch and the name of the branch. But you can also, or I'll just do this way. I'll just name it new branch. Okay, and I have done the branch, but not only should I create a new branch, as you can see, it is still on the master branch. I should check out to that branch. I should go into that branch. So the command for that is git checkout new branch. Now it shows switch to new branch and you're on new branch. Now this code base is currently in the new branch, you can see here. So whatever changes I do in this will not be reflected in my master branch. So you can see here, let me make this back to 50, and I will just commit these changes. So commit on new branch is the commit. So I've committed on new branch. Let me just check out to master branch, and you can see on the master branch index is still 45, and this is actually happening. If you go to the directory and if you open this file, it will still be 45, it won't change. This is how Git changes your file structure. But if I check out back to, let me see, if I check out back to for new branch, you can see my change 50 is already reflected. So now what I want to do, uh, so now when I've tested this new feature, and when I've added it, you can now what I can do is actually merge it. But for that I have to check out to the master. So since I've changed the same line, I think uh, I will be able to demonstrate what actually a merge conflict is. So now if I just git merge new branch with the master branch, this means I'm combining the master branch and the new branch together. Okay, as you can see, now if I type git log, so I'm on the master branch. As you can see, new branch has also arrived to the master branch, and all the changes in the commit on a new branch was actually made to the this branch, but it is now being reflected in the master branch. So that means that all the commits of the new branch were combined into the master branch. And this is how you can add features to your stable application. If you want to test new features, you can just make a new branch, go in that line, and then just commit it back. That's how it works. So all these were local concepts. Like everything you did now was only on your machine. But what does GitHub have to do with this? So let me just show you. Yeah. So how does GitHub work with Git? So it's basically the same concept. It's just that GitHub implements it on a website, on a live website. So what you would do is, if you wanted to create a new repo, you could absolutely do it. I think this is how you do it. Yeah. So you could create a new repository here, and you could manually add it through Git. The way I showed, the command for that would be uh, git add origin, I think. But there is a better way to do it, which I would advise to, is by GitHub Desktop, which easily provides you a visual way to do everything which I just did on the command line without having to remember the commands. So right now I have to add my repository to this application. So what I'm going to do is just choose my repository which is on the desktop. This is this Git and GitHub. So to be added to this GitHub desktop, it has to have a GitHub file in it. So as you can see, it immediately shows me to publish the repository. So if you're logged in with your if you're logged in with your account in the GitHub desktop, it will be connected to your GitHub account online. So if I publish this repository, it will ask me a few details of what this is. And if I publish, it should be all working. You should be able to see the changes. Yeah. If I just go to my repositories now, you can see that whatever I did on my lab on my local machine is already arrived here with the repository name, with the same repository name. So I'll just add a readme. So readme file is basically to describe what the project is about. Since there are a lot of open source projects online on GitHub, all these projects will have a readme file which will describe how to run the project is all about. So that's what I'm gonna do here. So readme has a special syntax. It is called a markdown file. It has a .md. This is how it works. So it has a special syntax which you can Google online. So this should be, make it bold, and this will be the first header. What I will do is actually I'll make something which I'll tell you. Now I'll comment these changes. So as you can see now the readme is updated with whatever I just typed. Now if I want it, I'll just hop onto Visual Studio Code now and just show you everything, a easier way to do everything I just did. So the first thing you would have to do is whenever you have a remote repository like on GitHub, now my project is connected with my remote repository. So I can just use, there are two important commands when it comes to synchronizing your code on your local machine with the code on your remote repository. They are push and pull. So pushing is for just basically, as it states, is whatever changes you made, you committed those changes on your in your local repository, and then you're pushing it to the remote repository. And pulling is the opposite. You're just pulling the new changes that are coming in, so that your repository and the working on the online repository are synchronized. So you're on the same page as the other teammates. So since I added a readme, I'll have to pull first. You can also do this by using the command line if you wish to. The command would be git pull, the same as this. It's just a visual way of doing things. And you can see that readme has been downloaded. It's been pulled down from my repository into my local project. Now the same thing I could do is, I made a mistake here. So what I will do is I will change the file, and Visual Studio Code actually provides you a very visual way to do all your changes with your source control in an amazing fashion actually. So there's a separate tab called source control here where you can handle all your changes. Whatever, every command I just did can be handled visually on Visual Studio Code. Okay, that's why it's named that. Okay, so as you can see, if you hover over these buttons you will see the exact meaning. So plus symbol says state changes, discard changes, and then open file. So state changes is the equivalent of git add. So if you do this, all you're doing is typing the command git add. So now the changes are being staged. So any changes I make in this file will be tracked by git. So any changes I make will be tracked by git, and it will show m that modified. The file is modified. You can see that I made changes to the file and it was modified again. And if I add it again, it will be staged. Again, show me. Yeah. So now I've staged the changes I've made. Now here is where you commit. This is equivalent to git commit. So just type in the message here, which is, I'll just change corrected readme readme file. So once you've done this, this is the icon to commit the message. This is equivalent to git commit minus m. If you commit this now, now this is committed on your local machine. This is equivalent to git commit. Now if you want these changes to be reflected online so that the other person knows that you've made some changes, all you have to do is git push. And you will be able to see that as soon as I refresh the page, as you can see that sub U was a capital U and now it has become small. So this is how you synchronize changes between your system and the remote repository online, so that everyone else gets to know the changes you have made and your contribution to the project. Now when it comes to open source, there's another important aspect. So you wouldn't be actually doing this, I mean you would be doing this, but there's another way, there's another extra step you have to do while contributing to open source projects. So if you just go to any of, if I just go to any of my repo, uh, let's take this for example. As you can see, this is not my, this isn't a repo that I have created. So this person is the owner of this repo. So what I can't do is directly clone this, and I can't just download it and push changes to it because I'm not the owner of this. I don't have the read and I have only read access to it, but not the write access. So what you have to do instead is fork it. So once you fork it, this is what's gonna happen. You're gonna you're making you will have a copy of that exact repo in your profile. So now what you're gonna do is open it, and there are two ways to do this. You can either copy this command, copy this URL, and you can type git clone and the URL, and it will just exactly download the entire project into your local system in the file folder which you specify. Else you can directly open it in GitHub desktop, which will also do the same thing. It will just open it up, it will just download all the project files and it will open it up. I would recommend using GitHub desktop because it easily syncs all your changes, and there's a lot of manual work while actually using the command line. You will have to manually add the GitHub remote URL as well as the upstream URL. So this is how it works. So whenever you made so suppose you made a change, you pushed your changes to your repo. So what will happen is you'll have to make a new pull request. Now pull request is nothing but a request to the original owner, this guy. I'm telling him to accept my changes to include it in the main repository. So once you made your changes, you'll get a new tab here called make compare and make a pull request, and all you have to do is make the pull request and then uh, click OK on it, and then the pull request will go to the original owner. He can review it and decide whether to merge the pull request or just tell you to make a few more changes, and then he'll accept the pull request. So that is all it is when it comes to open source contributions. So here I have a few here I have a few suggestions which you can follow. So go to this website, go to this repo called Mungel Awesome for Beginners, and here you can find a lot of pull request opportunities, as it says, awesome first pull request opportunities, and you can choose any language you're familiar with, and then it shows the projects which are available, especially for beginners. And I'm gonna go to Dart because I am familiar with Dart. So as you can see, you can go to issues. So every GitHub will have first the code uh, tab, and then the next to it will have issues where you can specify issues or you can work on the different issues mentioned here. So as you can see, you can tackle something mentioned beginner, something like that. Not somewhere here. So it will have tags like You can see here it says medium and what all the appropriate tags it will match. It will have all those tags here. You can see here it has a tag beginner. So this, if you're a beginner, you can start working on this. So all you have to do is go and you can ask them to assign this to you, or you can just reference this and make a pull request. All you have to do is type hash and this 2227, and this issue will be referenced in your pull request. uh, Let me just show how to make a pull request. I think that will be better. So you just have to type this after you push your changes, all the previous steps I showed. So right now there isn't anything to change. I can't make a pull request because there isn't anything that I have changed. But when you change something, there will be something changed, and will show here to make a pull request. It will give a comment box where you can type in some extra additional information about what you've actually changed, and then you can submit that request where it can be actually reviewed later. So right now we can see that my branch is even with the original branch. That means that both are at the same position and there haven't been any changes ever since I pulled the upstream branches, upstream repo. So another important thing to keep in mind while working on open source projects is to keep your this repo and this repo in sync, because they don't sync automatically. So if this repo has more commits, it will show here that this branch is of that repo is a few commits ahead of yours, and what you'll have to do then is git pull the changes from upstream master. So how you can do that here is let me just open the same project. So you can just open the same thing, uh, and you can actually choose git pull, and it shows here there are two different URLs. One is your name, the repository in your account, and the other one is the original repository called upstream. So if you pull changes from upstream, that means you're pulling the actual commits that are ahead of you. So every time before you start working on a project, make sure that your repos are synchronized and they're intact, and that so that you don't experience any conflicts. So pull them and then push it to your repo so that both of your repos will be synchronized and in one position. I think that is it for all the concepts I explained. You can check out these repos and contribute to them, and what you will get is sheer amount of knowledge and your GitHub repo to show off in your resume, which is considered an important aspect actually. So the more commits you have here, the more active programmer you are, and the more the employer can actually trust you on the skills you have. So make sure you record all your work on GitHub. It is an absolutely amazing place to keep a just keep a record of everything that all the work you've done. So I want to see how many people are there so I can do something. Okay, there are 7 people. Okay, why don't we do that in it quickly? So for the next 10 minutes, all the viewers are watching. Why don't we do a challenge, a simple challenge? What I want you to do is go to my account and hit follow. I'm just kidding. You could if you want to see what I'm working on. So go to this repo and do all the steps I told you. Fork it, click on fork, and then clone or download, open it in desktop, and then the project will be in your local file. After you've done that, open the project, preferably in Visual Studio Code or any text editor or anything, and you will have a similar README file. Let me just open the same project. So we'll have a README file. So what you have to do, that's why I mentioned this. So we'll just have to comment your names and make sure to do it in different lines so it doesn't cause a much conflict. And before doing this, what you have to do is create a new branch and check out to that branch with your name, create a new branch with your name and check out to it, and then make these changes and push them to a repo and make a pull request. And since there's only 7, I would say that I would probably give away a few of these stickers to people who make the first pull request. So do it. If you're from my college, you'll get these. So I'll be waiting. I'll wait for like 5 minutes. So you can submit your pull request. It will come right here, and whoever makes the first maybe 2 pull requests will get stickers from open source stickers, which I have. So just comment your names down below. So fork the repo first, clone it, create a new branch, check out to the branch, edit the readme file, commit the changes, push to your origin repo, and then make a pull request. Sounds like a lot, but let's see who does it first. And apart from that, if you have any doubts, you can obviously comment. I'm watching the comment section live. Please do let me know. I hope somebody's making a pull request. Is anybody working on it? Can I get a comment, please, if you are? How many viewers are there? Is anybody making a pull request? Okay, then I will. If anybody does make a pull, if anybody does make a pull request, uh, I'll make sure to give them the stickers. So until then, thank you all for joining me. I hope you learned something today. And if you have any doubts, you can reach me out on LinkedIn or Twitter. I'm very active there. So do let me know. And thank you. I'll be ending the stream now.